Pre-statistics. Rational exponents. Less objective. Simplify expressions that have rational exponents using a calculator. Less objective. Definition of rational expressions. Introduction. How should we define b raised to the 1 over n power, where n is a counting number? If you recall the exponent property, if I have b raised to the m power and raise that number to the n power, then that is equal to b raised to the m times n power. Now, this is true if we let n be equal to a half and m be equal to 2. So if we consider b being 3, we have b to the m power equal to 9, because 3 squared is 9. Now if we take b to the m and raise it to the n power, we have 9 raised to the 1/2 power. But by the exponent property, that is equal to b raised to the m times n power. So 3 raised to the 2 times 1/2 power, well, 2 times 1/2 is equal to 1. And 3 raised to the power of 1 is equal to 3. So we have illustrated that 9 to the 1/2 power is equal to 3. The non-negative number 3 is called the principal second root, or most of the time it is called the principal square root of 9. And if you remember, we write it radical 9. So there is a connection between the radical and fractional exponents. Let's do another illustration. If m is equal to 1/3 and n is equal to 3, we can take 8, raise it to the m power, and raise that number to the n power. We have 8 to the 1/3 raised to the 3rd power. Well, we can think of that as b raised to the 1/3 times 3 power. Well, 1/3 times 3 is 1, so b to the 1st power is equal to b. So we know that 2 to the 3rd power equals 8. So this suggests that a good meaning of 8 to the 1/3 power is 2. Because if I take 2 and cube it, I get 8. And if I take 8 and take the 1/3 power of it, I get back 2. So the number 2 is called the 3rd root, or more commonly called the cube root of 8. And it's written using this symbol. Now we call the 3 an index. So if you have a normal square root and you don't see a number here, it's understood to be a 2. But in this case, we are talking about the cube root, or what number do I cube to get 8? And that number is 2, because 2 times 2 times 2 equals 8, and 2 times 2 times 2 is the same thing as 2 to the 3rd power. So let's define this idea. Definition: for a counting number n, where n is not equal to 1, if n is an odd number, then b raised to the 1 over n power is the number whose nth power is b, and we call b to the 1/nth power the nth root of b. So from our last example, 8 to the 1/3 power was equal to 2, because 2 to the 3rd power is 8. And we call 2 the cube root of 8, or we could call it the 3rd root of 8. If n is even and b is greater than or equal to 0, then b raised to the 1 over n power is the non-negative number whose nth power is b. We call b raised to the 1 over n power the principal root of b. So if you recall from the example, we had b being equal to 9. So if we take 9 and raise it to the 1/2 power, that gave us 3. So 3 is telling us if I take 3 and square it, I get back 9. Now what if n is even and b is a negative number? then b raised to the 1 over n is not a real number. We can't take negative 9 and raise it to the 1/2 power and get 3, because 3 squared does not equal negative 9. Notation: we can represent b to the 1 over n power by using this symbol. So there is a connection between rational exponents and radicals. The denominator of the fraction is equal to the index. Let's do some examples. Example 1. Simplify these numbers 1 through 6. For number 1, we have 25 to the 1/2 power. 25 to the 1/2 power is 5, because this is asking what number do I square to get 25. And that answer is 5, because 5 squared is 25. So whenever we see an exponent of 1/2, we can think of that as a square root. What number do I square to get 25? And the answer is 5. Number 2, we have 64 to the 1/3 power. So this is asking what number do I cube to get 64? Well, the answer is 4, because 4 cubed is 64. Number 3, and in this case is negative, so negative 64 raised to the 1/3 power means what number do I cube to get back a negative 64? Well, in this case, since n is odd, we can have a negative number here, and it works, because if I take negative 4 and cube it, negative 4 times negative 4 times negative 4, I will get a negative 64. Now, the big idea with this is we're going to use the graphing calculator to determine these values. So let's verify them. If I take 25 and raise it to the 1/2 power, I get 5. 64 raised to the 1/3 power is 4. And if I take negative 64 and raise it to the 1/3 power, I get negative 4. It checks. The one thing you have to be careful with is you got to make sure you use your parentheses as needed. Whenever you take a number and raise it to a fraction power, you need to use parentheses. Number 4, 16 to the 1/4 power is 2, because if I take 2 and raise it to the 4th power, I get 16. Number 5, negative 16 to the 1/4 power. If you recall, we have to raise powers before we multiply, so 16 to the 1/4 is equal to 2, but then we have this negative on the outside, so negative 1 times 2 is a negative 2. And number 6, negative 16 to the 1/4 power is not a real number. N is even, and we can't take a number, raise it to the 4th power, and get a negative number, because a positive times a positive is positive, and a positive number raised to an even power is always positive. So it's not a real number. Let's verify these three using the graphing calculator. 16 raised to the 1/4 power is 2. Negative 1 times 16 raised to the 1/4 power is negative 2. If I take a base of negative 16 and raise it to the 1/4 power, the calculator tells me that there's an error. It's not a real number. And again, it's not a real number because if I take a negative number and square it, I get a positive number. And the square root of a positive number is a positive number. It can never equal a negative number. Thanks for watching.